Thank you. This is the question paper that is coming from an exam. Now, learners were subjected to this question paper, now which is question number 3 in a normal question paper. This question, now they tell us the melting point of some organic compounds are given in the table below. Are given A, B, C, D. A, just a brief analysis of the table before reading the question. A, it's a ketone. B is a ketone. All they are ketone anyway. Therefore, the chain length will play a part. Then they do have the same intermolecular forces. They have dipole forces in addition to London forces. So the distinctive forces in this ABCD is it's a dipole forces. The melting points are given on the right hand side. Now they're telling us to say, let's go to 3.1.1. They're telling us to say, to which homologous series do the above compounds belong? From our brief analysis, we have already said they are all ketones. Fine. Then 3.1.2. The melting points of A and B and A, B and C are compared. Remember, we're comparing same here. When we're comparing same, if you still remember, we go for structure, which is chain length. Fine, let's go. Write down the controlled variable. What is controlled when we're comparing the same homologous series? Is this homologous series, of course. Homologous series or functional group. Right, homologous series or functional group. You'll get the mark there, 1 mark. 3.1.3, they are telling us to say the melting point of C and D are compared. If you look at C and D, both of them have got 5 carbon atoms, but the other one is branched, another one is not branched. You still have the same homologous series, it's fine. Therefore, chain length also plays a role. Now, fully explain the difference in the melting points of these two. 4 marks. Remember, when we're comparing same, we go for structure. First point will be now C. If I start with C, C has a longer chain length, or surface area. Okay, I've got the greater surface area than D. That's the first point. If we start with D, D will have the shorter chain length than C, or the smaller surface area than C. Second point will be about the strength of intermolecular forces. So the longer the chain length, the stronger the intermolecular force. Therefore, C has stronger intermolecular forces than D. Thanks, you get a mark. You already have got 3 marks now. The 4th mark will be when you compare the energy. Therefore, if I start with C again, C requires more energy. Because once you have got stronger intermolecular forces, you require more energy to overcome the intermolecular forces than D. You can even say, hence C has higher melting point than D. That will be the case. You have given the examiner now more than enough. All the marks will be yours now. We come to 3.2.1. The table below, on this one, the table below shows the results obtained from an experiment to determine the vapor pressure of different straight chain primary alcohols. So all in the table are primary alcohols at 300 kelvins. You've got primary alcohol with 1 carbon up until 6 carbon. Okay, they are primary, then we'll be having hexane 1 all, the 6th one. Define the term vapor pressure. We have already said it in the beginning to say vapor pressure. It's a pressure exerted by a vapor in equilibrium with its liquid in a closed container. So I think we defined that one when we were starting to say the vapor pressure is that one. Yeah, it's here. The vapor pressure, it's here. To say vapor pressure is the pressure exerted by a vapor in equilibrium with its liquid in a closed system. Fine. Now we move to 3.2.2. Then we'll write down the suitable conclusion. As I said, conclusion is based on the data collected during the experiment. You can see moving from alcohol with 1 carbon atom to 6, the vapor pressure is decreasing. Therefore, I can make a conclusion now that as the chain length increases, increases, the vapor pressure decreases, or increase in chain length decreases the vapor pressure, or increase, if you want to say chain length, you can talk about the surface area. Fine. Or the molecular mass, also that one will be another option, molecular mass, because in this case we know that from C1 to C6 molecular mass increase. Now we go to 3.2.3. They're telling us to say, write down the UPEC name of the alcohol with the highest boiling point. Highest boiling point will have, remember, boiling point and the vapor pressure, they are normally inversely proportional. If you increase the boiling point, the vapor pressure, it decreases. So the compounds with the higher boiling point have got low vapor pressure. In this case, which one has got the lowest vapor pressure is number 6. We give it the UPEC name, therefore it will be your hexane 1-ol. Some they write it as 1-hexanol. I think it's also accepted. 3.2.4. Now they're saying again, for 1 mark, they say to us, the experiment is now repeated. In this case, repeated at 320. We have increased the temperature now. So therefore, will the vapor pressure of each compound increase, decrease, or remain the same? We know that when you increase the temperature, obviously now the vapor pressure now will have to also increase because we produce more vapor now. So you just write increase. And that one is a bonus question. That's all the 14 marks in this question. So you see how simple it is when you're comparing the same homologous series. Therefore, we go for chain length, the strength of intermolecular forces, and the energy. Yeah, in that case. So that's the one of the comparisons here. That, as I said, there are only 2 types of comparison in this section. You'll be comparing compounds from the same homologous series, or you'll be comparing compounds from different homologous series. So that's how this question will always be like. Thanks a lot for now. We'll be engaging with other problem solving in this regard, so that at least in this section we'll be rest assured of getting all the marks that are due to you. Thanks. Bye for now.